All right, so let's jump into it. What we're going to be doing today is simple interest. And the main thing that we want to think about with simple interest is that it's going to be like a stepping stone, right? It's sort of the building block for everything else. Okay. And what simple interest is just taking the idea of a percent and adding a time component to it. Okay. So let's suppose that, I want to borrow money from you, and, I say, okay, I'll give you back the money with interest. Maybe I'll pay you 10% interest. Okay. Whether or not I pay you tomorrow or I pay you 10 years from now sort of makes a difference, right? To you, right? Being out your money for one day is not a big deal. Being out your money for 10 years, right? That is a big deal, right? So if you were going to lend your money out for 10 years, you would want to be compensated more so than lending your money out for one day, right? And that's the idea of interest, right? We want to add a time component to a percentage. Okay, so that's what our main idea is. Interest is a percentage with a time component. Okay, so what we're going to do when we look at interest is we're going to say, okay, we want to figure out how much of the interest we're going to charge. Okay, and so what we do is we say, when we take a percentage of, we multiply, we'll just throw an extra factor in there for time. Okay, right? So here's our simple interest formula. I equals PRT, okay, where I is the interest amount, P is the principal or starting amount. So if we were borrowing money, P would be the amount that we borrow. R is the interest rate, and T is the amount of time. Okay. Now, one thing that I want to note with interest rates, okay, they're typically given as an annual rate. Okay. So that's something to keep in mind. The percentage rate R is generally given as an annual rate. So when we say something like 5% interest, that means that if you were to borrow for exactly 1 year, we would just charge 5%. Okay. Right. The other thing to keep in mind when we talk about interest, I is going to be an interest amount in dollars, R is an interest amount as a percentage. So it's important to sort of keep straight the ideas. Otherwise, we'll put numbers in the wrong spot. Okay, so let's look at an example. Let's suppose a friend asks to borrow $300 and agrees to repay it in 18 months with 14% simple interest, right? Where that's an annual rate. Okay. So what I do is I go to my problem and I identify what numbers I was given, right? Borrowing $300 is the P. The 18 months is the amount of time. So I can write that as T. Okay. Here's the thing about time, though. Since the interest rates are given as an annual rate, it's usually easiest to make sure that my time is also in those same units. Okay. So what we can do is we can say, all right, let's convert that to years, right? So my conversion, I want to multiply by a fancy form of 1. And for my units, I want to end up with years and get rid of months. Okay. So 1 year and 12 months are the same. Okay. So this will cancel out my months. And then I have 18 divided by 12. Okay. You can leave it as a fraction or you can write it as a decimal. Okay. But we're going to be plugging numbers into our calculator, so decimals are probably convenient anyway, especially if they come out nice. Okay. If that was like 1/3 years, maybe I would leave it as 1/3 so I didn't have to deal with the repeating decimal. Okay. So that's our time, and then our rate is 14%. I want to write that as a decimal though. Okay. And the amount of interest, I, is what I want to find. Okay. So I think it's very helpful to be able to go through and identify what do you have in your problem and what is it that you're looking for. Okay. And then we plug in the formula, right? So our formula was I equals PRT. I want to find I say great. So we have 300 times 0.14 times 1.5, and I multiply those up on my calculator, and we get 63. Okay, so how much interest will you earn? $63. Okay, I want to expand on this problem a little bit. I want to ask another question that wasn't part of the original question. How much does your friend have to repay? Okay, so they have to repay what they borrowed and also the interest, right? So the amount that they have to repay is going to be P plus I. So 300 plus the 63, so $363. Okay, nice job. All right. Now, there are formulas for the repay amount. You can actually build it in. And if you were to look it up, if I say, okay, what's the amount that they have to repay? Okay, that's P plus I. And I is equal to PRT. And then I can do some fancy math work where I say, oh, both of these terms have a P in it, so I can factor it out. Okay, so we could get a formula for how much we have to repay. But I don't want to dwell too much on simple interest formulas because I really want to think of it as a stepping stone. Okay, when you go out in your life and you borrow money from like banks and stuff, you don't ever use simple interest like this. And if you go to buy a car, sometimes they say, oh, we're going to compute things using simple interest. What they're really doing is compound interest, though. It just, things are arranged funny. So simple interest isn't really something that you ever really see used directly. You might, like I said, if you're borrowing from a friend, that would make sense because it's very simple. There's nothing complicated about it. Everyone knows what's going on. Okay, but if you go to banks and stuff, you won't really see this. Okay. So what I want to do is I want to jump in and show you compound interest. Okay, and compound interest is kind of the same idea. We just make it make a little bit more sense. Okay. So let's spend our time on compound interest. All right. And here's why compound interest makes more sense. If I think about simple interest, okay, let's suppose we borrow money and I'm going to pay it back all at once, okay, then it makes sense to have like a separate computation for interest. And when I pay back the amount plus interest, okay. But usually with bank accounts, you don't really plan on that. Like if you borrow a bunch of money for a car, you don't say, don't worry, I'll pay you back in 5 years, trust me. You make payments on it as you go, okay? Or if you're saving money in a bank, you don't tell them, oh, I'm going to save money for 5 years, and they say, okay, that's fine. We won't give you anything until the 5 years are up. You kind of want to see them give you the interest as you go, and if things change, maybe you got to take money out at some point. Okay. So what we want to do is look at this idea of compound interest. And with compound interest, what we're really doing is just taking that interest and regularly adding it to the balance as we go, instead of waiting till the end. So that's really the only difference conceptually. Okay, and this idea of reinvestment, right? We take our bank account, whether we're borrowing or saving. Okay, we'll think about saving money for now, right? If I save money after 1 month, the bank says, all right, we're going to give you interest. And what they do is they just add it directly into my account. Okay, so that's what's called compounding. Okay, so what I'm going to do is we're going to develop a math formula for compound interest, but then I'm going to show you a couple different ways to compute it. Okay, so here's kind of the idea. We'll look at this example. Let's suppose we deposit $1,000 in a bank account. It offers 3% interest compounded monthly, and we want to look at how our money will grow. Okay, so first of all, remember I said before that interest rates are typically given as an annual rate. Okay, and if we are looking at a bank, they would usually advertise that as like the APR, that stands for annual percentage rate. Okay, so that just means that, okay, that's the percentage rate that you get per year. Okay, and since we're looking at month to month, we're just going to divide that by 12. Okay, so if it's 3% annually, then it's 3% divided by 12 monthly. But you'll notice if I'm going to multiply or divide, I don't want to leave it as a percentage. Let's switch it to a decimal, and that way we don't have to worry about any funny business occurring later. Okay. So as a decimal, this is how much interest we're getting per month. Okay. So this is going to be our interest rate R. Okay. So in the first month, we've deposited $1,000. Our interest rate R is 0.0025. So if I want to compute how much interest, I can use my simple interest formula, I equals PRT. So here's my P, here's my R. And because I converted this to a monthly rate, okay, my time is just 1 month. Okay, so my units, oops, mouse flying. So my units already match up. I don't need to worry about converting them over. Or another way to look at that is, instead of thinking of this as simple interest and doing I equals PRT, we can just say, I'm just taking a percentage of how much money is in there, right? We don't even need to really put in the time factor. It's already sort of built in, right? That we're saying, all right, well, I'm looking at 1 month. I just want to take a percentage of how much I have in that month, right? Okay. So I take my principal times the rate, and we get $2.50. Okay, so if my interest amount is $2.50, and I started with $1,000, then at the end of the first month, we're going to have $1,002.50. Okay. So when we start the second month, we're not starting with $1,000 anymore. For the second month, we're starting with a little bit more, $1,000 plus the $250. So when I want to compute how much interest we get, we take our $1,002.50, multiply it by our rate, and now you'll notice that I get slightly more interest than I did the first month. Not by much, but it's slightly more. And the reason that it's more is because I'm taking a percentage of a slightly larger balance. Okay. So for the end of the second month, right, I take my starting balance for that second month, I add the interest, $2.51, and now I have $1,005.01. So this is the amount at the end of month 2. Okay. Okay, this is what makes compounding drastically different from simple interest. Because in simple interest, we say, okay, I'm just going to compute your interest once, and that's it. It doesn't matter how long you borrow the money. You'll get more money, right? You know, the interest will be more if the time is more, but you don't do anything with the interest until the end. The idea of compound interest is, no, like we compute the interest every month if it's compounded monthly, or every quarter, or every day, whatever the time unit is that we agree upon. Okay. And we add the interest as we go. Okay. So we can compute a table for what compound interest looks like, right? So here was our month 1 that we talked about. We started with $1,000. We computed the interest, and so I add that interest on. And then we also computed month 2. We said, okay, now I'm starting with the ending balance for month 1. Okay, so this and this match. I get slightly more interest, I add that on. So that's my starting balance for month 3. When I compute the interest, because of rounding, it actually comes out the same as month 2. I add that on. Okay. Then starting with month 4, that's big enough that my interest has gone up another penny, right? I add that on. And so you'll see the interest the amount of interest that we add grows. So our balance is getting bigger, and the more time we go on, the faster it's getting bigger because we're adding more interest each month. Okay. Now, there's a pattern to how this goes up by, and I'm not going to go into the pattern too much, but maybe we'll just sort of highlight it, and then I'll give you a formula. If I look at my starting amount P, after 1 month, okay, my ending amount was, my ending amount A was P plus I, and the way that we computed the interest I was just taking P times the R. So if I were to factor that, I would get P times 1 plus R. And that's what I have here. This is the 1 plus R. Okay. And this part over here is the P. Okay. For the second month, I take that value that I had at the starting month and do the same thing, multiply it by 1 plus R. But I have this 1 plus R times 1 plus R times my original 1,000, so it gets squared, right? For the third month, I take my 1 plus R and multiply it by the value that I had at the end of the second month. Okay. And again, doing a little algebra, we can see, oh, okay, I can pull out that 1 plus R. Okay. And that's where this formula comes from. Now, remember that the R we had here, we converted to a monthly rate. And typically what we do when we're given an amount of interest is we're given an annual rate. So in our formula, what we're going to do is we're going to sort of build in the conversion to, for example, a monthly rate. Okay, so here's what the compound interest formula looks like, and I want to break it down a little bit. Okay, so A is the ending amount in the account, or the future balance. Okay, so, okay, and we have a typo. This shouldn't be after n years, this should be after t years. Okay, so A is the ending amount, or the future balance. P is the starting amount, or the principal, that's why we call it P. Okay, R is the interest rate as a decimal, and we're typically going to have this as an annual rate. Okay. And if this is an annual rate, then T is going to be the number of years, and N is going to be the number of compounding periods per year. Okay. So to give you an example, if we're talking about monthly, then N is 12. If we're talking about daily, right, if I want to compound interest every day, then there's 365 days in a year, usually. Okay, we'll ignore leap years for the purpose of this class, right? Keep things a little bit simple. Okay, if we were talking about quarterly, right, we call them quarters because there's 4 of them, right, per year. Okay. All right. So what I want to do is I want to look at computing interest 2 different ways. I want to look at it using formulas and then also using your calculator. Now, one of the things you'll notice is that you weren't given 1 formula here, we were given 2. And that's because we might want to find different things. Okay, so if I start with a $1,000 balance in my account and I want to say, okay, how much is going to be in there after 10 years? Okay, I want to find the ending amount. So then I would use, this formula here. But if instead I said, okay, I want to have $5,000 10 years from now, how much do I need to put in my account right now? Then what I want to find is the starting amount. So then I would use this version of the formula. Now, these are really the same formula. They're just algebraically solve for either P or A, right? So if I wanted to take this formula and solve for P, I would just divide by all of this stuff. I would have A divided by this 1 plus R over N to the NT. And that's exactly what we have over here on the right, okay? So they're not really two different formulas, but when we're doing problems, right, it feels like two different formulas. Okay, so let me show you, I've sort of listed out some steps here for finding stuff on your calculator. So if you have like a TI calculator, like a TI 83 or 84 or 84 plus or silver, right? Any of the TI calculators, this will work. If you have a different calculator, you have like a Casio or something like that, it might still have this, but it's going to be a completely different set of steps. Okay, so let me bring up a calculator and I'll walk you through how to do this. So first what you do is you press the apps button. And the first thing on there should be finance. And the first thing on there is this TVM solver. We hit enter. So this is our solver. Okay. And so this is what it looks like. Now there are some differences between the symbols that we had up here when we do formulas and the symbols when we're entering in the calculator. Okay. Here they have this big capital N. And n is actually, the capital N is equal to little n times t. It's the total number of compounding periods. Okay, so we'll go through an example in a second. The other big difference is that the interest rate, it says I%. It's actually asking you to enter it as a percent, not as a decimal. So if it's 3%, you would leave it as 3 and not put in 0.03. Okay. It says PV instead of P, right, for present value, right, instead of principal, same idea. PMT stands for payment. When we start talking about things where we're depositing payments or making monthly payments, we'll do that. But for now, that's just going to be 0. And FV is the future value. In our formulas, we used A for amount, I guess, I don't know, but it's the future value, same thing. Okay, then we have this P over Y and C over Y. In your calculator, it allows you to make these two different things. In this class, we never want them to be different. We always want them to be exactly the same as n. Okay. And the idea is your calculator allows you to, say, make payments maybe every 2 weeks when you get your paycheck, but maybe you're only charged interest once a month. Okay, you could make these separate, but that's a complexity that we're not going to deal with. Okay, this payment end begin thing, we're always going to leave at end. And for now, it won't be necessary. But when we talk about annuities and installment loans, then that'll come into play. Okay. If we leave it on end, then we'll always match up with our formulas. Okay. So let's look at an example. Let's look at the problem that we were just sort of setting up where we deposit $1,000 in a bank account offering 3% interest. Okay. What I want to do is I want to look at doing this problem two different ways. So I'm going to have the formula on the left, and I'm going to use the calculator app on the right. Okay, and let's see how it goes. All right, so first let me list my given information. We're depositing $1,000, right? So I see, okay, P is equal to 1,000. It's 3% interest, so my interest rate is 0.03. Compounded monthly, okay, so the N is 12. How much will I have at the end of the year? So I want to find A. So if I go back to my formulas, I want to use the A equals formula. A equals P parenthesis 1 plus R over N to the NT. Okay, and then I fill in my values, right? I have 1,000, 1 plus 0.03 divided by 12, the 12 times, and it's at the end of 1 year, so my time is 1. Okay, so on my calculator, the way that I would enter this in is 1,000 times parentheses 1 plus 0.03 divided by 12, close the parentheses. And now, how the exponent works depends a little bit on your calculator. If your calculator actually has a superscript, if it moves it up high like this, then you don't need parentheses. You can just do 12 times 1 and you're done. Okay. If your calculator, see if I can change it. Okay. If your calculator, when you hit the exponent, show you again really quickly. If I hit my exponent and it just puts a caret here for the things that are in the exponent, then I want to put them in parentheses. Okay, here it's times 1, so it won't actually make a computational difference, but in most problems it does. Okay, so we get $1,030, and if I round to the nearest cent, we'll have 42 cents. All right, I'm going to change that mode back. Okay, if I was doing this on the calculator app, my present value is 1,000. Okay, the I% is 3. Okay. So I hit apps, finance, TVM solver. For the n, you can actually do multiplication in here, right? So remember the big N is little n times t, so I could just do 12 times 1. Okay, and it'll automatically do the multiplication for me. Here, 12 times 1 is obviously 12, but for other ones where it's complicated, the idea is you don't have to do math in your head. Okay, so the I% is 3, the PV is 1,000. Okay, payment should stay 0. Final value is what I want, but I want to hit enter again because I want to go down here and adjust these. These should be equal to the little n, which is 12. Now, one of the things you'll notice, if I change the first one to 12, it will automatically change the second one for me. So that's convenient. But then I want to find the future value. So what I do is I go up to future value. Oh, what if you had gotten 1,030 as an answer instead of 1,030.42? I think typically what we want to do is round to the nearest cent. To me, that makes sense in financial math. If you're doing this on the homework system, I think it'll usually tell you how much to round to, but if it says round to the nearest cent, it would mark 1,030 as wrong. Okay, when we get up to future value, if I just hit enter, that's for entering a value. What I want to do is make it solve. So if I look at my calculator, solve is above the enter button, in this case in green, so I hit the green alpha to be able to hit solve. And then it will solve for me. Okay, so it says this future value gives me negative 1,030. And again, if I round, it'll be 0.42. Okay. All right, so the other thing that I wanted to mention, when you're using this calculator app, it's going to give you negatives like almost all the time. And the reason that it does this is because they're trying to use what I think are probably good accounting principles, right? So if I'm giving the bank money and me giving the bank money is positive, then the bank giving me money is the opposite direction. So it gets a negative on it, right? If instead I said, no, giving the bank money, I'm losing $1,000, then when I collect my money, then it would be positive. Okay. For our purposes, you can always just ignore the negative. Okay. We're not going to mess around with that. So we would just say, oh, okay, how much will we have at the end of the year? We'll have $1,030.42. Okay. Any questions so far? Okay, so now let's look at the exact same setup, except instead of at the end of 1 year, let's look at the end of 10 years. And this is where I want you to notice the main difference between compound interest and simple interest. For simple interest, if I'm saving the money for 10 times as long, I'll get 10 times as much interest. So instead of $30 right, it'll give me $300, right, or $304.20. Okay, so if this were simple interest, we would collect at the end of 10 years $1,304.20. I'm just putting that there as sort of a reference. That's not part of the question. And I did that a little bit mentally. You know, if you were doing that, you should probably use the formula and be real clear about it. Okay. All right. We only have to do this one way or another. You don't have to use both the formula and the calculator app. So you just kind of pick one. But I'm a really big fan of using this calculator app because it makes things very simple. Okay. So for example, if all I wanted to do was change the t to a 10, I would say, oh, up here we have 12 times 10 instead of 12 times 1. The I percent stays the same. The present value stays the same. These are still monthly, so that's still 12. Okay. So then I hit solve, and I get $1,349.35. Okay. All right, so you'll notice that that's more money than simple interest. And the reason that it's more is because every month the amount of interest is getting put into our account, and we're getting interest on that interest. Okay. Now, one of the things I want you to know, though, it's more. It's not like astonishingly more, right? Notice that the interest on the interest doesn't make this jump up by a huge amount. Because if I'm starting with $1,000, okay, my first month, I'm maybe getting like $2.50 interest. So how much interest do I get on $2.50? Not much, right? Okay, so it adds something, and it can be significant, especially over a long period of time, but it's not necessarily super drastic, okay? It gets more drastic if you have higher percentages and longer periods of time, okay? Then it grows faster and faster, okay? But for shorter amounts of time and for smaller interest rates, it doesn't make as big as noticeable a difference. Okay. All right, let's look at another one. How much should you put into a savings account now? So that's asking me how much to start with. Okay, so this is asking me to find P, or the present value. Okay, at 7% interest, so my interest rate is 0.07. Compounded quarterly, so N is 4. To end up with, so I want an ending amount A, or future value of $6,000 in 8 years. So T is 8. So as I read through the problem, I write down what those pieces of information are. And for me, that's the safest way to avoid making a mistake. Okay? That way, when I'm entering stuff in my calculator, I can read directly what it is, and I'm not like reading a bunch of words as I'm figuring out what to put where. Okay? I think the best way to avoid making simple mistakes is to not do two things at once. Okay? And I don't know if you guys have this experience in math classes before. You get a test back and you're like, oh, I know how to do that, but I made some silly mistakes. I left out some negatives, or, I added 2 and 3 and got 6 because instead of adding, I multiplied. Silly mistakes like that happen. And what I like to do is create habits that will make me less likely to make those silly or simple mistakes. Okay. And I find that if I write out my information directly in the symbols that I'm going to punch in as a separate step than punching them in, then I'm less likely to make a mistake. Okay. So then if I want to compute my ending amount A, my present amount PV using a formula, okay, here the formula P, remember it's A divided by that parenthesis thing. I'll just write it down here. And so then if I plug in the numbers, and you can plug them in here or just plug them directly in your calculator, but for taking notes, I'll write it down. So we have 6,000 divided by 1 plus 0.07 divided by 4 to the power of 4 times 8. Okay. So 6,000 divided by parentheses 1 plus 0.07 divided by 4, close the parenthesis, to the power of 4 times 8. And we get $3,443.89. I already forgot the number. $34.43.89. Okay. And we could have also used our calculator app. Okay. So the capital N is going to be 4 times 8. The interest rate is 7%. We don't know how much we're starting with, so I can leave that blank for now. I want to end up with 6,000. And the payments per year, the P over Y stands for payments per year. C over Y is compounds per year. Okay. I'm going to change that to 4 and go back up. It's the present value I want to solve for. So I hit alpha and hit solve. And that gives me the number I wanted, $3,443.89. How does n equal 32? So remember that the capital N is equal to little n times t. So in this problem, the capital N, okay, is 4 times 8. Okay, so when I entered on my calculator, I enter 4 times 8, and when I hit enter, it automatically does the multiplication for me. Okay, so I don't have to mental math, even like simple multiplication, I don't have to mental math. Okay. Any other questions? Okay, well then I think that we're probably good for today. So that's, 2 more sections, right? I know that simple interest was kind of a short section, okay? And then we just have one more section tomorrow on the effective rate, and we'll talk about that and go through some examples. But then otherwise you should be set to be able to do most of your homework. So tomorrow we'll definitely have some time afterwards to look at homework problems if you get stuck on anything. Okay, so you can just, ask live then, or you can just, as you're going through, just hit the Help My Instructor button, either way. So if you have any questions, stick around, but otherwise I think that we're done with notes for today.